Awesome. Let's go to lab 2. So in this lab, the main goals is to understand what MCP model context protocol is and how it allows you to connect assistants to external tools and other data sources. So we will build a simple high-level MCP server, and um, the key components, and we'll look at the key components, including the server and the client aspects of MCP and the transport layer. So please follow along as we go through this notebook. And again, you can access this through the Start notebook, or it's also inside Jupyter Notebook directory. So here we're setting up our MCP server using the fast MCP library, which is a high-level SDK um, that allows us to expose certain functionality to be invoked by external MCP clients. So here we instantiate a fast MCP server, and then we use MCP tool decorator to add some functionality. These are some basic examples where add is adding two numbers and subtract is subtracting two numbers. And then we initialize a server here. When you run the cell, what it does is it should create an MCP server.py, as you see here. So it just writes that code to a Python file, which will then be used by the MCP server to host this. We will take a quick detour to talk about how to run MCP server on your local machine and integrate that into something like Cloud Desktop. So for that, I'll actually use my downloaded version, but you don't have to follow along, maybe because we will not finish setting this up. We will mainly focus on how to access MCP server programmatically in the rest of this lab. But I just want to show how you can theoretically set this up on your and connect it to your cloud server if you want to have your cloud desktop talk to MCP servers that you set up and build yourself. So sharing real quick.
In other words, what you're saying is we are going to use the local MCP server that we created with two functions in the tools, add and subtract. You are showing what is possible if you connect with MCP server outside, but
That's
not
correct.
intended for the exercises.
That's correct. We don't. So yeah, the example I'm showing will walk through what it would look like on the Claude desktop app to set up and connect to a local MCP server. Okay, hope you can see my screen. So this is just my Claude desktop application. So here I will go to settings, developer, and this allows us to set up a local MCP server. So I will hit edit config, which actually, as the instructions show, it takes me to my Claude desktop underscore config file, which I will open, and let me stop sharing. So essentially, I set this up earlier. So this is just my preferences from Claude config. So that's not related, but this is the main part, MCP servers. So
Are you sharing
essentially,
screen?
apologies, I didn't actually click share. Thank you for that. So this is my config file to set this up. So earlier, when I showed what I
Oh,
showed you in the
sorry.
Claude
I
desktop.
think it's, I think you are sharing the wrong window, or
Yeah, we see very small. Uh,
obviously it's a desktop with
yeah.
a notes.
Oh, sorry. There we go. Okay. Do you see my cursor
Yeah.
window? Okay.
Uh, Sorry, this Jason. Okay, cool.
Yeah.
Okay.
So this is the main part where the example that we're seeing earlier in the notebook that you set up and run locally can be connected to your MCP server. So the cell that we ran generated the MCP server.py file. So we would just specify, in theory, we specify the paths to that MCP server.py file, and then that would allow you to use the functionality um, that code has in your local applications like Claude Code and Claude Desktop. Varun, you have your hand up. Question?
Yes, slightly like
Sure.
confused. Like, are we supposed to install Claude desktop on?
No, no, you don't have to. I'm just showing this as an example to show that the MCP server you build, you can use every day in applications like Claude
Sure.
Desktop. Yeah, and
All
how
right.
you
This
would
is like
configure
an.
that. Yeah, yeah,
Okay. Thank you.
yeah.
And then like we can. What are the other ways we can use it other than the Claude? Like in like even in the like a Jupyter notebook, we can call off like a this MCP file, MCP server. Is that what you?
That's correct. So the main focus of the rest of this bootcamp will be on how to use it in a more programmatic way, and that's what I will go over next.
Thank
Questions.
you.
So in principle, can I run this in a container or something, serve just like other Python-based web server?
You should be able to, yes. Yeah.
Okay,
You can
thank you.
containerize this as well, this entire workflow. Yeah.
Okay, got it. Thank you.
Can I pause a little bit? So everyone, with the questions, we love the questions that are coming in the chat. If it's possible, can you post those in the lecture channel on a Slack so everyone can answer those so we don't lose the track of the questions that you're asking here. So if you have any questions, it's better to ask them in the Slack so all the TAs would be able to respond to each of them. Thank you. Back to you, Bennett.
Thank you. And do you see my notebook again?
Yep.
Yeah.
Okay, perfect. So yeah, just wanted to show you how you can configure. So any MCP server that you build locally, you can use it in applications like Claude if you choose to. You don't have to do that, but just wanted to show an example of how you would configure that. So let's go to the actual part where we talk about how to programmatically access an MCP server. So in this section, we set up the MCP server, and what this is doing is starts the MCP server and runs it in the background. And we see the process ID for that. So this is the server aspect. Now let's talk about the client side of it. So the MCP client has 6 broad functionalities. There's the init, which sets up and does the resource management. And then you can connect to the server. So connect to server does this locally, while connect to server HTTP does this through HTTP protocol. And then there's list tools. This will be very useful because on the client side, if you want to know what the server, what features and tools the server is providing, this is, in our case, we're setting up both the server and the client. So we obviously know what tools we're writing and providing in the server. But in practice, you may be just an MCP client accessing an MCP server that's hosted by someone else. In that case, list tools would allow you to discover the available tools in the MCP server. And then call tool would allow you to execute those tools. And finally, cleanup would just allow, again, this is more if you're setting up the server, it allows you to clean it up and get rid of the process once you're done. Any questions so far?
Is there a better way to understand the NIM, the working of the NIM here? That's a container that is running in the background, or how is it functioning?
Yeah, so I think we should step back a little bit. So we've changed directions. What you saw in the previous notebook was a NIM that was deployed in the cloud as a cloud endpoint that was deploying a Llama model. We changed direction slightly. We're no longer dealing with the NIM in this part of the bootcamp in Lab 2. We're working with an MCP server where we're setting up the MCP server and the functionality ourselves.
Okay.
So this
right.
this does not we're not using a NIM in this notebook at all.
All right. Okay.
Yeah. Okay, so let's look at the actual how this is set up. So after we import the necessary libraries, we set up the MCP client. So here we initialize this. This is mostly boilerplate code, so you should be able to, in practice, take most of this and to replicate it and as you set up your own MCP server. And it provides you functionalities to connect to the server, locally connecting to the server through HTTP, to list the tools, to call the tools and clean up everything that we saw listed above. And here we're actually calling those. So if we run the cell, should be running. And let's execute that. So we've connected to the MCP server, which is right here. And then we call all of the functions that we set up. So we called the add tool and the subtract tool, and we got results back in each case. Is everyone good so far? Are you able to follow along?
Maybe a question, like why did the client need to have a dual connection?
Sorry, can you repeat the question again?
Yes, so there are dual connections for the client, like via HTTP and also like natively, I think. But then why two of them?
I see. Yeah, so we need both types because sometimes you may be you can connect to a local MCP server, right? Where you deploy it locally and both your client and your server are on the same local endpoint. In that case, you wouldn't have to go over HTTP. We also provide the HTTP functionality because sometimes you may deploy the server on an actual remote server. So you have to go through the network and HTTP protocol to go through because you're no longer, the server is not sitting on the same machine the client is accessing it from.
Oh, okay. Makes sense. Nice. Thank you.
Yeah.
So essentially, this code is really boilerplate for many applications, regardless whether it's on one machine and on distributed setup or whatever, right? That's kind of how to approach it.
Exactly.
Yeah.
I'm sorry for a conceptual question. So first, we kick off the server, which is running in the background, and then we run a client to request something and get the results. Is that correct? And then we can kind of kill the server after this. Is that correct?
That's correct. So initially, we define the server here, and then this writes it to MCP server.py. And this is necessary because when we kick off the server, which we're doing here in this cell, it looks for MCP server.py and then runs this server in the background using subprocess.popen. And here we see that process is alive and running. So that sets it up. And then we go over these parts, which are mostly the client side of things on how to initialize and connect to that server.
Got it. Thank you.
And maybe a question here is like, where is the LLM part in this? Like I see a server and a client. Where is the LLM?
There is no LLM part. So we're starting small to just understand how MCP works and to just show some simple examples.
I have a question.
Got it. Thank you.
Yes.
So again, just to repeat the question previously, like this MCP server has nothing to do with AI. The MCP client has nothing to do with AI. The client basically just run test case. Am I right?
That's correct. And this is this is true in a lot of cases. There's many agents where you can build agents and they may not be actually AI in the end. They could be doing some simple logic or some simple tasks that are more logical rather than a neural net. And in this case, that is the case where the functionality that we're exposing through an MCP server is just add and subtract. In theory, we can replace the add and subtract to do much more complex tasks like exposing an LLM endpoint.
Okay, I have a slightly off-topic question. Like, say I don't have Cloud Desktop. So let's say you connect your MCP to Cloud Desktop. How do you know? Because adding is kind of simple enough that Cloud can do easily. How can you know for sure that that Cloud Desktop is actually using your MCP?
That's a good question. I don't have the answer to that. Have any of the TAs tried integrating MCP with Claude?
Yeah, I think Vinit, you can go up. There's some screenshots about it. Yeah. So here you will see a request, a tool request right below. I'll add those numbers for you right in the second screenshot. Yeah.
Okay.
So here you can see a tool call that's made. And here you can see that it is calling the MCP server for you.
Oh, okay, I see.
Awesome.
Thank you.
Yeah.
Also, it looks like you can update the server and add tools to it without restarting it. Is that generally the case, or do you sometimes, I don't know, can you make large enough changes that you really need to restart the server for it to work?
That's a good question. You should be able to make changes without restarting the server.
Okay.
Question just for the client. I saw here it's in the parser add argument. It kind of shows it's by default it's looking at a local connection. But in principle, if I'm visiting, like reaching out to this server from another computer, I need to kind of change to a HTTPS to the URL, right?
That's correct. Yes.
Okay. So, thank you.
Awesome. So let's move forward. So what we saw so far was we have an MCP server set up, and we have the client call that and call the two tools that we have set up. And finally, once we're done with it, we can kill the server. So now let's add some functionality to this MCP server by adding the tools multiply and divide. So take a few minutes to do that, and then update your server. Here, if we look at the actual tools, we're defining two additional tools, multiply and divide. That's what you're seeing here. And then, so that updates the MCP server when you run that to include those. So just make sure the MCP server is updated. I restarted my MCP server, and then add the tool test tools. So for multiply and divide as well. So
Vinith, where did we put the error handling?
I didn't do error handling. I didn't have time to do that.
Okay.
You can do a try except. Yeah.
I pointed out where you need to change it to divide instead of subtract.
Oh, sorry. Yeah.
Yeah.
Thank you. Yeah.
And I think you want to do the error handling in the server versus client.
Yes, you do the error handling where you're defining the tool itself. So
Right.
here. Yeah. In the final part, let's do this task where you switch the MCP to using streamable HTTP. I'll stop my sharing to avoid distractions as I go up, scroll up and down, but take a couple minutes to change that. Yes. this is, again, a simple example, so I'll just show you the solution. So where we're defining the MCP server, we just change the MCP run to include transport equal streamable HTTP. What are we doing on time? Any questions so far?
Is between this last change, essentially one rather than the other, standard or whatever it was, versus HTTP.
Sorry, I didn't fully catch the question. Can you repeat that?
Can you explain the difference when we just did this switch to an HTTP transport? Can you explain the difference between what we have just changed it to what we had before?
Yeah. So actually, so the communication layer has, you can use the standard IO or HTTP. Standard IO is mainly when you're doing it for local use. While the HTTP is when you're setting it up for a server to be accessible via HTTP. That's the main difference. So the original setup was set to only, use the MCP server locally. With this change, in principle, when you set this up, you can access it from an external server.
So can you set up both at the same time?
So essentially when you have this, that would also include your local, right? Because since it is running locally, it's accessible. You just have to specify it as localhost, and then the MCP server.
Vineet, not to distract you, but for the TAs, there was a question in the lecture materials of someone having an error, and a couple of the attendees said they were having it as well. Oh, Scott just answered it. Thank you, Scott. Back to you, Vineet.
Sorry, I didn't see what issue others were having or where it was answered, but is it the port is already in use error? Because that's what I'm getting.
Yeah, someone got the address already in use error, and that's the conversation happening in the lecture materials chat.
Oh, lecture materials. Okay, great.
So if the port is in use, I think Scott and Vineet, we can ask people to change the 8000 to something else so that you can use another port, so you don't use each other ports for that one.
Yeah, that assumes the server. I assume it will spin up on a subsequent port, so maybe like 8001. But really, you should just one of the options or one of the cells below is to kill the server. And that's the last cell in the box or in the lab 2 is to kill the server PID. I can see that being a problem now. If you've got multiple running, you won't have the process ID. I think I'll be able to put a command in chat for killing all of them.
Perfect.